Hello my esteemed viewers. In this tutorial, finding of resultant in a coplanar concurrent force system is clearly explained with umpteen number of problems of engineering interest. Of course, in the previous tutorial, that is tutorial number 2, we had done 4 problems, 4 of course primitive problems, wherein we explained as to how we can find out the resultant of a concurrent force system. In this tutorial, we continue with that with problems which are of moderate complexity to high complexity. Right. The learning from the previous tutorial has been splitting a force into its components is called resolution. Combining components into a single force is called as composition. Force can be resolved with respect to any reference line or axis. However, we chose to resolve the forces in 2 orthogonal directions, one along x and one along y, because in most of the engineering problem solving exercises pertaining to engineering mechanics, we do resolve the forces along x direction and y direction. Resultant of a force system is a single force which can replace all other forces in effect. A system that has a resultant will not be in a balanced state. There will be jerk in horizontal direction, there may be a jerk in the vertical direction, and there may be a movement also. However small the movement may be, the existence of a resultant will be showcased by the system in terms of disturbance. Anyway, we are trying to find the disturbance causing force, which is called as resultant, of course, which will represent all the other forces in effect. And in order to make the system to be in equilibrium, we need to just reverse the direction of the resultant, but maintaining the same magnitude, and such a force is called as equilibriant. So opposite of resultant is equilibriant. Of course, existence of equilibriant is desirable in any engineering systems. And we will go through the problem. The 2 structural members, 1, 2, one of which is in tension. This is in tension because an arrow is going out, and the other in compression, arrow is coming towards the joint. Exert the indicated forces on point O. This is the point of concurrency. Determine the magnitude of the resultant R of the 2 forces and the angle theta which R makes with the positive x-axis. The inclination of 3 kilonewton force is given in the form of a slope. If you take tan theta over here, tan theta equal to opposite by adjacent. Opposite by adjacent is 4 by 3. Therefore, theta we are going to get to be 53.13 degree. Therefore, Fx, sigma Fx, algebraic sum of all the horizontal forces is 3 cos 53.13. 3 cos 53.13 because it is going in a rightward direction, and 2 cos 30. 2 cos 30, the horizontal component of the 2 kilonewton force will also be acting rightwards, therefore that is also positive, and if you add up we get 3.53 kilonewton, the algebraic sum of all the horizontal two inclined forces. And here is the 3 kilonewton force, and here is the horizontal component, and here is the horizontal component. As far as vertical components are concerned, Fy is minus 3 sine 53, minus 3 sine 53 acting downwards, plus 2 sine 30 acting upwards. As far as this force is concerned, we will get a net force acting in vertical direction is minus 1.4 kilonewton, and we can just replace the entire system by 2 forces. One algebraic sum of horizontal forces 3.53 and the vertical forces minus 1.4. The resultant is square root of 3.53 square plus 1.4 square, which will give us 3.8 kilonewton, and theta is tan inverse of 1.4, that is sigma Fy divided by sigma Fx, that is 1.4 divided by 3.53. we will get an inclination of 21.63 in this direction. From the positive x x-axis, but to make a roundabout we need to find out 360 degree minus 21.63 degree. That will be the measure of this particular direction measure of this particular resultant with respect to positive x-axis. Anyway, this resultant is to be placed over here. Actually, when we place this resultant at the point of concurrency, we can afford to remove this force and this force, and this is the net effect that is happening at the point of concurrency. Right. The sixth, and we have numbered the problems in a cumulative order. 4 problems we did in our tutorial 2, and this is the second problem in tutorial 3, which counts to be 6. If the equal tensions T in the pulley cable are 400 Newton, this is also 400 Newton, this is also 400 Newton, determine the resultant force exerted on the pulley by 2 tensions. This can be, though we feel that one force is over here, one force is over here, we can take the net effect is being played on this particular pin, which goes through the heart of the pulley. Therefore, this forms a point of a concurrent force system. Therefore, this point is drawn over here, and this tension is written. This tension is written like this, and the angle between them is 60 degree, because this T makes an angle of 60 degree with respect to horizontal, and this T, this tension is acting already horizontally. Therefore, it's a simple problem. Fx sigma Fx equal to algebraic sum of horizontal forces equal to 400 cos 30 as far as this T is concerned, plus 400 a readily available horizontal force, which will give us 600 Newton. And as far as sigma Fy is concerned, there is only one force which is having vertical component, that is 400 sin 60, which would amount to 346.4 Newton. And if we take if we square them and if we add them up and take the square root, we will get the resultant magnitude, that is 692.8 Newton. And theta is tan inverse of sigma Fy divided by sigma Fx. We will get it 29.19. The resultant is over here, which is inclined at an angle of 29.9 degree. Right. This is 692. Yeah. Magnitude is 692. The guy wires, cables, the guy cables are those cables which are tightly tied to a tower in order that it will never sway due to wind. We have seen this for our electric poles, okay, along the roadside. The guy wires will always be under tension. As a matter of fact, any cable can only be subjected to tension, and it cannot be compressed because a cable doesn't have any stiffness. The guy cables AB and AC are attached to the top of the transmission tower. Here it is. So this represents a typical concurrent force system. The tension in the cable AB is given to be 8 kilonewton. Determine the required tension T in AC such that the net effect of the two cable tensions is a downward force at point A. Determine the magnitude R of this downward force. There is a tension, given tension value, and we are asked to find out tension in AC, given that the resultant will be acting downwards, vertically downwards at A. Therefore, direction of the resultant is given. It is a vertical force. It is a lone vertical force with horizontal component missing. Therefore, we can make use of the principle that we laid out in our tutorial number 2. The vertical component should be the algebraic sum of vertical components of tension in AB and tension in AC will be equal to the resultant, and sum of the horizontal components of these two tensions must be equal to 0 because resultant happens to be vertical. So we make use of this Q and we will solve the problem. TAB is 8 kilonewton, this angle is theta, and TAC is to be determined, and this is the resultant. The red line represents the resultant acting downwards. This is theta and this is alpha, and theta and alpha can be computed by making use of this geometry. And this is theta is over here, so tan theta equal to opposite is 40 and adjacent is 50. So theta equal to tan inverse of 40 divided by 50, that gives us 38.7 degree. On the same token, alpha, tan alpha is opposite. Opposite is from here till here, that is 50 meter, and the adjacent is from here till here, which is 30 meter, the height. So alpha is tan inverse of 50 by 30. We will get an angle inclination of 59.03 degree. Therefore theta is 38.7 and this is 59.3. This problem reduces to the previous problem. Now the vertical component equal to, see, horizontal component equal to 0. The angle is referred with respect to vertical. Therefore, if the horizontal component goes in this way, it is minus 8 sine 30.7. And horizontal component of TAC goes this way in positive direction. Therefore, TAC is sine 59.03. Sine of the angle comes from the fact that the angle of reference is with respect to vertical. Therefore, TAC happens to be 5.83 Newton upon solving this equation, and we will find out the resultant by just equating sum of the algebraic sum of the vertical forces itself is the resultant. So it is 5.83, this one 5.83 cos 59.03 and 8 cos 38.7 will give us resultant equal to 9.24 kilonewton. Due to guy wires which is being tied like this and another guy wire which is being tied like this, okay, in the event of a wind or in any event which causes tension in these two wires will culminate in a vertical resultant which is acting vertically downwards over the tower. Of course, that is the resultant, right? Next problem, two forces are applied to the construction brackets. This is the construction bracket as shown. Determine the angle theta which makes the resultant of the two forces vertical. Determine the magnitude of R of the resultant. This is very much similar to the previous problem, but however the figure should not be confused to be a three-dimensional force system. Of course, this is the plane that we are going to consider. This is the plane. The entire the force system can be represented over XY plane. We are interested, we are not writing the forces acting on this particular plane because it is inconsequential. The forces can be captured in the plane if this is x-axis and if this is y-axis, this is going to be xy plane. Therefore, this problem, seemingly three-dimensional problem, is nevertheless a two-dimensional problem. Okay. Algebraic sum of horizontal components equal to 0, sigma fx equal to 0 because the resultant of the two forces is vertical, and we will just make a careful resolution. 800 cos 70, this is 800 cos 70, it is acting like this, which is positive. On the other hand, 425 cos theta, theta is unknown, is acting like this because looking into arrow the direction of the force will be like this. Therefore 425 cos theta, and we will get cos theta equal to 273.61 divided by 425, and theta amounts to cos inverse of 273.61 by 425, 49.9 degree, and this is 49.9 degree. Therefore R is sum of the algebraic sum of the vertical components. It is 800 sine 70 acting vertically down, 425 sine 49.9 which is also acting vertically down. Therefore we will get an R value equal to 1076.8, which is like this, which should be acting somewhere like this here at the point of concurrency, right? That is the resultant. Now it is desired to remove this spike. Spike means some kind of a fixture done on the wooden beam or wooden column, let us say. A spike from the timber by applying a force along its horizontal axis. We need to remove this along the horizontal axis. Effective force should be along the horizontal axis. An obstruction A, some kind of a box like this, this is an obstruction A of a particular dimension which is given over here. An obstruction A prevents the direct axis. There is no way of pulling this spike directly along horizontal axis. Therefore, two cables are tied and forces are applied. That two forces, one 1.6 kilonewton and the other P. This one is P along one cable, and this is the other cable along this particular line, which is applied force is 1.6 kilonewton. Therefore, these two cables are under tension and it is being pulled because of this particular obstruction. and the other P are applied by cables as shown. Compute the magnitude of force, magnitude of P necessary to ensure the resultant T directed along the spike, along the axis of the spike, let us say. Also find T. So we will just solve this. Tan theta here, tan theta is 100. This you consider this small triangle. It is 100 divided by 200. So tan theta is 100 by 200. Theta is tan inverse of half, so it will be 26.56 degree, and this is the angle. On the other hand, alpha, if you consider this as the alpha, tan alpha is opposite is 150 and adjacent is 200. 150 by 200, it will give us 36.86, and we will equate sigma Fy equal to 0 because the resultant is nothing but a horizontal force. So horizontal force means sum of the horizontal components of these two forces is nothing but the resultant. Therefore, its vertical component is 0. We will use the same trick. So P sine 26.56 going up should be equal to 1.6 sine 36.86, because the vertical component of 1.6 is acting downwards, vertical component of P will be acting upwards. Therefore, we will get the value of P to be equal to 2.15 kilonewton upon simplification. So this is 2.15 kilonewton. Therefore, R equal to sigma Fx. Actually, R equal to square root of sigma Fx square. Anyway, it will become sigma Fx only. So Fx is, we will resolve that. That is called as T over here because the resultant is named as T. So T equal to 1.6 cos 36.86 plus 2.15, just now we found this, 2.15 cos 26.56. We will get the value of T equal to 3.20 kilonewton. So that is the force that is being applied in order to remove the spike along the axis of the spike. Combine the two forces P and T acting on this particular dam cross section. It's a dam cross section. Two forces P and T, which act on the fixed structure at B. So this is P, this is T, into single equivalent force R. Single equivalent force means that is none other than the resultant. So we will calculate tan theta. Tan theta, it's over here. Tan theta is BD by AD. Okay, no, this is the theta. This is theta, sorry. Tan theta is BD opposite by adjacent AD. BD is 6 sine 60. So this angle is 60 and we want BD. We will make use of this right angle triangle. This angle is known to us. And the hypotenuse is also known to us. It is 6 meters. Therefore, sine theta is opposite by hypotenuse. Therefore, we will get to know as to the value of BD. So BD is, we will make use of this particular length. It is 6 sine 60, and AD is AC, that is 3 meters, plus CD. CD is 6 cos theta, 6 cos 60, because cos 60 is CD by hypotenuse. Therefore, we will get 6 cos 60, and tan theta happens to be 0.866. Therefore, theta is tan inverse of 0.866, that is 40.9 degree, and this angle is 40.9 degree. This angle is 40.9 degree. Okay, we'll continue. Rest of the problem should be easy. Sigma Fx equal to, here the direction of the resultant is to be found out. There are no other conditions, okay, like previous problems. So Fx equal to 800 direct horizontal force, which is going in the positive direction, minus 600 cos 40.9 degree. And if it is 40.9 degree with respect to horizontal, this angle will also be 40.9 degree. Therefore, it is 600 cos 40.9 degree, it will be going in this direction, looking into this particular sense. So horizontal component of 600 Newton is going like this, therefore it becomes negative, and this angle is 40.9 as this angle is 40.9. So this is equal to 346 Newton. In the same token, sigma Fy equal to, now there is only one force which will be having vertical component, that is 600 Newton. It is minus 600 sine 40.9 degree. This should be degree. Yeah. 40.9 degree. Yeah. That will give us minus 393 Newton. So R equal to square root of 346 plus 393 square. We will get 524 Newton to be resultant, and the sum of the horizontal forces is positive, therefore it is going rightwards. It is amounting to 346 Newton, while the vertical component is 395, which is going down. Therefore resultant is tan inverse of sigma Fy divided by sigma x, 393 by 346, that is 48.63, and this is 48.63, and it will be actually acting over here. Okay, it has been replaced. Okay, this is equivalent system, so all the forces can be removed and can be converted into a single horizontal force and single vertical force. Making use of this, we will find out the single resultant, and single resultant should act at the point of concurrency. Now we can as well remove this P as well as T, because this will be suffice. This is suffice to represent the entire system. Right, the forces F1, F2 and F3, all of which act on a point A somewhere over here over a bracket, on the bracket, are shown to act on a bracket. Find the resultant effect on the bracket. So we will just take out each and every force and we will try to resolve this. So this force is acting at an angle of 35 degree, F1 600, so F1y, F1x. So this is 600 cos 35, 600 sin 35, both of them positive. And here, as far as this force is concerned, 3 by 4, and this will become 5, because it is hypotenuse. 3 square plus 4 square, that is 9 plus 16 under square root will give us 5. So hypotenuse is 5. So we can make use of, we will solve this problem in a different way. Wherever sin theta matters, we will say 3 by 5. Wherever cos theta matters, we will say 4 by 5. So we can avoid the drudgery of calculating theta, right? So F2 is 500 Newton and F2y is 500 cos whatever, cos theta. Cos theta is 4 by 5, and F2y is sin theta, which is 3 by 5, and here 4 by 5. F2x is 500 into 4 by 5. So as far as F3 is concerned, we need to calculate angle alpha over here, and alpha can be calculated by making use of these dimensions. And here till here it is 4 minus 0.2 minus 0.2 will get us this angle, to this distance to be 0.2. Okay, from here till here it is 0.2, because from here till here it is 0.2. So minus 0.4 minus 0.2 will give us 0.2, that is being recorded over here. And as far as this height is concerned, it is 0.3 plus 0.1, 0.4. So the side lengths are given, which forms this particular triangle, subtending an angle alpha. Therefore angle alpha can be calculated. So alpha equal to tan inverse of 0.2 divided by 0.4, it will be 26.6. So this angle is, I will write it down, this angle is 26.6. 26.6. So everything is known to us. It is a straightforward problem, but acting on a bracket. It's a real world problem, of course, right? So sigma fx 600 cos 35 plus 800 sine 26.6, because the angle is referred with respect to vertical and the horizontal components goes this way, plus minus 500 into 5 by 4, minus 500 into 5 by 4. 5 by 4 is cos theta, sorry, sin theta. Yeah, minus 5 by 4, it's going like this. it should be 4 by 5, sorry, minus 500, because the horizontal component is going like this, minus 500 into, yeah, into, correct, it is 5 by 4, 5 is hypotenuse, 4 is adjacent, no problem, 224.7, and it will be going like this. The entire system can be replaced by a one single horizontal force, 224.7. In the same token, Fy is F1, that is 600 sine 35 minus 800 cos 26.6, because it is a vertical angle. And as far as F2 is concerned, it is 500 sine theta. Sine theta here means 3 by 5. So 5 plus 500 sine 3 by 5. So this is positive because it is going up. So it is minus 71.2, and this is minus 71.2. Therefore, the entire system is equal to one horizontal force, algebraic sum of all the horizontal forces, and one vertical force, algebraic sum of all vertical forces, and the resultant is 235.7 Newton, and it will be going like this. And this is the inclination, and this inclination is tan inverse of sigma Fv Fy divided by sigma Fx, sum of the vertical components divided by horizontal components, that will give us 17.6 degree. This is 17.6 degree, and this resultant has to move over here, and it should be placed over here. And now we can afford to remove all the other three forces. Now determine the force magnitude F, this one, F, and the direction theta with which it is inclined with respect to vertical, measured clockwise from positive y-axis, that will cause the resultant R of the four forces, 1, 2, 3, force, F is also involved, of four applied forces, to be directed to the right. The resultant of all the forces at the point of concurrency is directed to the right. It will be like this. It has to be like this. Of course, it has to be like this. This is the resultant, and its value is given to be 9 kilonewton. It is 9 kilonewton. It is similar to first 2 or 3 problems that we did, but anyway, it comes with a practical application. Here again, it's a joint. It's a joint in the truss, in a framed structure, of course. Sigma Fy equal to 0 because the resultant is horizontal, and Fy, this is a direct vertical force, 20 plus 7 sine 30. 7 sine 30. This is also a vertical force going up, looking into this arrow, minus 11 sine 30. This vertical force, vertical component of this force is directed vertically downwards, minus F cos theta. Of course, this is already going down, and if you write the vertical component, it will be like this, and it is cos theta. F cos theta equal to 0. Therefore, F cos theta equal to 18. Upon simplification, we will get F cos theta equal to 18. Here, we should understand that there are two unknowns. One is F, other one is theta, and some condition is given to us. 1. Sigma Fx equal to 9, because the resultant of all these forces is a force directed towards the right. Therefore, 7 cos 30 going right, plus 11 cos 30, that's also going right. The horizontal component of 11 kilonewton, 11 kilonewton, minus F sine theta. So the horizontal component of F will be directed like this, towards left, and it is theta is attached over here, therefore it becomes sine theta equal to 9. The value is already given. Therefore, F sine theta is equal to 6.6 upon simplification. Therefore, tan theta, if you divide equation 2 by equation 1, F and F will get cancelled, and we will get sine theta by cos theta. Sine theta by cos theta is nothing but tan theta. Tan theta equal to 0.366. And that is 6.6 divided by 18 will give us 0.336. Therefore, theta is tan inverse of 0.336. That is 20.13. So the result, the force F makes an angle of 20.13 degree. Therefore, F equal to, and substitute the value of theta over here, either here or here, we will get, and we are substituting to equation number 2. Therefore, F equal to 6.6 divided by sine 20.13, and we will get the resultant to be 19.7 Newton. A vertical mast AC, this one, this is AC, vertical mast, in figure, supports the cables, supports the cables, 3 kilonewton, take cables with tensions 3 kilonewton and 7 kilonewton respectively at the angles as shown. BC is a guy wire. Which holds the mast with the end B located at x from A. So the distance between end B and A is x meters from A. If the resultant of the force system is to be 12 kilonewton acting vertically down, see, this is the resultant which is acting vertically down, and with the magnitude equal to 12 kilonewton down the mast, what should be the distance x? So this problem comes with a different unknown. We are not concerned with the forces because everything is given to us. What we need to find out is, given all the other forces, we need to find what is the distance that the guy wire is to be tied at the ground level in order to generate a resultant of R that is vertically going down with a magnitude of 12 kilonewton. Given AC in the AC is the mast, and these tensions are one in 3 kilonewton, and the other wire is, so here it is 7 kilonewton. So 3 kilonewton, 7 kilonewton. Okay, and we need to find the tension in BC also. We can find out, because this is the guy wire. Guy wire has to suffer from tension force because it will be holding the mast intact against wind forces. This problem is again similar to the previous problems, except that here we are provided with the known magnitude and direction of the resultant. The unknown is the distance x. We shall make the point C as the origin because this happens to be the point of concurrency. Two tensions, tension in the cable, guy wire, and also the resultant force. Make C as the origin. Looking into the figure, in the triangle ABC, in this triangle, we can calculate cos theta and sin theta. Here again the diagram is brought out, and this is theta. Theta is this angle. So cos theta is adjacent. The height is 50 by hypotenuse. Hypotenuse is 50 square plus x square under the square root, according to Pythagorean theorem. So cos theta is 50 over square root of 50 square x square. And sin theta is x over 50 square plus x square, because this is sin theta opposite x over this one. So x over hypotenuse, it is 50 square plus x square. So we got to know the value of cos theta and sin theta in terms of the unknowns. So here the unknowns are the theta as well as the x. Since the system has vertical resultant force, the sum of the horizontal component vectors of all the forces must be 0. So 3 cos 10, this inclination is 10, 3 cos 10 acting rightwards due to this particular cable, plus 7 cos 35, this is 7, this is 25, here till here it is 25 plus 10, 35, 7 cos 35 minus t sin theta, this is t. Tension is acting in the wire BC, so tension will be acting like this, and the component of this force along horizontal direction is minus. It is because it is going like this, therefore it is t sin theta. We can sketch that for the sake of clarity. So the tension in CB will be acting like this, therefore its horizontal component will be like this, which is negative. Okay, we'll continue with that. So 3 cos 10 of this force plus 7 cos 45 of this force, 25 plus 10 minus t sin theta, this force, because theta is referred over here, and we don't know this value. Okay, this angle can be taken as theta anyway. Once again we will make it clear by writing theta over here little big. Right, we will continue. We'll continue with this. 3 cos 10, 7 cos 35 minus t sin theta equal to 0. Therefore t sin theta is 8.688, and in place of sin theta we will substitute this t into x over sigma 50 square square root of 50 square plus x square equal to 8.668, and if you square that in order to remove the square root, we will get t square x square equal to 8.688 square, because we are squaring both LHS and RHS for the sake of parity. So this will be 8.688 square, that is 75.486. Upon cross multiplication, we will get this equation number 1. In the same token, in equation 1, the number of unknowns are 2, the T, tension in the wire, and X, the distance. Therefore, we need one more equation to solve them. We know that the algebraic sum of vertical components of all the forces is equal to the given resultant, which is also vertical. Therefore, it is 3 sine 10. This is 3 sine 10 acting vertically down, and 7 sine 35 acting down, and t cos theta acting down equal to 12. So 3 sine 10 plus 7 sine 35 plus t cos theta equal to 12. So therefore 4.536 upon simplifying these two terms, t cos theta equal to 12. So t cos theta equal to 7.464 upon further simplification. And for cos theta we have an expression, ready-made expression, like 50 divided by 50 square plus x square, and equal to 7.464, and upon squaring we will get 50 square, that is 2500 square into t square equal to 7.464 square, which will be 55.71, and if you cross multiply this, square root will go and we will get 50 square plus x square. Therefore we have two equations now with unknowns t and x. Now using equation number 1, 2500 t square equal to t square x square for 75.489, and how it is possible. See, 2500 t square equal to, in the earlier equation we have t square, the expression for t square, and we will substitute that, that's all. For t square we have an expression over here, we will make a substitution. Okay, t square equal to t square x square divided by 75 into 75.489 into 55.71. So in place of this value, okay, so x square equal to 33.87, therefore x equal to 33.87 into 0.58, that is 58.2 meters. So this tutorial is closed with this problem. In the next tutorial, the concurrent force systems that are in a state of equilibrium will be elaborated. Until then, bye, and if you have liked this video, kindly subscribe. Thank you.